Programming Languages and Design Concepts, a research on how non-declarative language can be used to implement an expert system. In our research, we will be focusing on implementing an expert system using a non-declarative language.
In this research, to prove the concept, we will be implementing an expert system to diagnosing and treating human respiratory system diseases. This is the part 2 of expert systems and non-declarative languages. Before moving on to the depth, let's take a quick look at the areas covered in the version 1. Artificial intelligence and the usage of artificial intelligence. Expert systems and the language usage in expert systems. Then issues arise with the current expert systems. So we have introduced kind of a new solution to these problems arise.
During this research, we discovered that though expert systems have been introduced before 5 decades, still they are not popular among developers and users due to the difficulty of implementation and the usage of special languages. In this version, we mainly focus how to use non-declarative languages for the implementation of expert systems.
In here, we are supposed to discuss about the design architecture of an expert system which is totally used non-declarative languages. To achieve the effect, we uses an expert system which was developed using declarative languages. Then, we would like to examine the same expert system can be converted into a non-declarative design architecture. An expert system for diagnosing and treating human respiratory system diseases. Okay, this is the system which is used to diagnose and treat human respiratory system diseases. So the system is implemented using the Prolog language and the Flex expert system shell. So from now on, we are going to consider how the system has implemented. First, we will take a quick look at the basic design of the expert system. Okay, now let's consider the characteristics of the expert system which is used to diagnose and treat human respiratory system diseases. The first one, ability to make decisions using incomplete or false information given by the patient. Second one, ability to questioning the patient to complete the incomplete information given by the patient. Third one, ability to making decisions on the inconsistency way. Finally, explaining the reasons to the doctor's own decisions. Here you can see the expert system is act as same as a human doctor. Okay, here you can see some kind of an illustration for the approach to the expert system. So now let's see how it works. When doctor treats a patient, first he or she gets a rough idea about possible diseases by using abductive reasons. That means from the symptoms made by the patient, he will decide the possible diseases. Then he will apply the deductive reasoning methods to confirm roughly identified diseases. Which means, again, from the diseases, he will clarify the symptoms. Most of the experienced doctors and also medical students are use these two methods only in diagnosing process. And also, most of experienced doctors use induction reasoning methods to select most possible diseases in between the above two methods. So this is the approach which is used to implement this traditional expert system. Except those three reasoning methods, sometimes doctors use other reasoning methods like model-based reasoning and case-based reasoning. But sometimes the doctors are unable to achieve a proper diagnosis using those reasoning methods. Therefore, it is essential to consider both abduction and deduction reasoning methods to make good and more powerful medical expert system.
As the primary attempt, this system should be able to exhibit the characteristics of a human doctor. Therefore, as same as other traditional expert systems, this expert system also has three basic components named as user interface, inference engine, and knowledge base.
First, let's consider the user interface of the system.
User interfaces are used to have the interconnection between the user and the system. Therefore, all the inputs which were entered by the user gets through the user interfaces, and all the outputs of the system can be viewed to user through the user interfaces.
Okay, here you can see kind of an illustration of the user interface. So we will be focusing them on more detail in the latter part of this presentation. Okay, now let's consider the inference engine of the system.
The inference engine is used to compare the knowledge of respiratory system in knowledge base with the symptoms which supplied by the user in a logical manner in order to find a suitable answer.
Now we are going to consider about the knowledge base of the system. Okay, this is the most important part of this expert system. In other words, this is the place where the declarative languages are used. So in here we are going to consider it in detail. First, let's see how it is implemented.
Knowledge base consists of 6 different modules. These modules are named on their processors. There are diagnose module, treatment module, question generate module, clinical test module, explanation handling module, diagnose depth recognition module.
Okay, here you can see a basic design structure of the expert system. You can see all 3 components and how they are divided into sub-components as well. Now let's consider these components one by one. Okay, now let's see the modules in the knowledge base in detail. Diagnose module. Diagnosing module is the main and the most important module out of 6 modules in the knowledge base. Functions of that module can be classified on several steps. Listing out all the possible diseases using abductive and deductive reasoning methods. So this is the main task of the diagnose module. If an additional information required during the diagnosing process, this diagnose module requests that information from the question generation module. The next important thing is this will passing information which is coming from the diagnosing process to the explanation handling module. Finally, the diagnosing module is responsible of calculating